Hello, everyone. Welcome back to my channel. Thank you for visiting my channel again. I am so glad to see you again. So in this video, we are going to talk about literals. What does literal mean? Well, literally speaking, literals are constant values. So in a program, you might be going to represent a fixed value, and this fixed value or constants are called literals. So we are going to use Eclipse so I can visualize what I am, so I can visualize properly the concept about literals. Okay. Okay, so we are going to explore literals. Okay, so going back to our example we have seen in the last video, we actually initialize the variable into a certain data value, and those values are actually called literals because we actually make it as a constant in our program. Okay, so I'm going to write the main method here, public class uh, static, sorry, not public class, public static void. Okay, that's the syntax for this. Main strings, string. Well, why do I always say strings? So args, which are arguments, and then we will be putting all our examples here inside the main so we can see how it shows in our program. Okay, so I'm going to show you a char data type. I will be writing it char. The name will be tab equals um, here with forward backslash t. Okay. Okay, the data value of this char tab variable is actually a forward slash then t. So this is actually tab. Okay, this is the literal of tab. I'm going to write system dot out dot print line, and I'm gonna write tab. So if I'm going to call this one, so there's nothing. So but there's actually an output there. The output is actually tab. You cannot see the tab because it's just like it skipped. You know how tab works, right? So when you press tab, it means it gives like an indentation. So that's how tab works. So that's um, a char data type. So let's that is for the char literal. So we actually input the fixed value of the variable tab, and it holds this character. Okay, as um, we know that variable can hold only one character. One data. Okay, one data type. Okay, so now let's talk about numeric literals. So this one is char type literals. I'll comment this one out. Char type literals. Okay, so let's try to have another one. Let's make another example for numeric literals. Okay, so as you know, there are different types of integer types, right? Um, So apart from the examples I have provided in the previous video, um, for example, last time I actually presented to you a kind of a kind of mm, double data type. So I would say expo say simple. Simple double is, we'll say, equals to 1.2. Okay, so we can write it out. Simple. Okay, so it will show in our program. See the tab, it prints the tab, but also it prints the 1.2, so it skips one line. Okay, so that is for that one. But we have also another double literal, I mean another double type literal that you can do in Java, such as this one. I will do like to write double, and I will say exponent. So for exponent, we can actually write one, for example, 1.2 E12. So you can actually do like this. So this is 1.2 times 10 to the power of 12. Okay, this is an exponentiation kind of expression. Okay, so if I'm going to write, I mean, if I'm going to output that one, exponent. So let's see how it looks like. Sorry, that is not the one. Okay, so it actually just prints out this 1.2 E12. And you can also perform computations for that. Say, for example, we would like to multiply simple, simple and exponent, we can do so. It's syntactically correct when we multiply this one or do other operations for these two types of double data type. Okay, so this exponent form, this can be useful, especially if the numbers are just too big, or if the numbers are too small. You can use exponentiation like -12. You can do like that. This is also acceptable. If it's too big or too small, I think it would be better if you do this kind of literal of doubles. Okay, so take note that any numeric literals that have decimal points are all doubles. Okay, so before, actually, last time, I gave you an example like this one, float. For example, float, say, float, what do you think is the best variable for float? We say, I would say float is temporary float. So I will write the value of pi 3.1416. This is okay, let me write the value of pi then, 3.1416. But you see, it's actually asking us, let's see, let's read, type mismatch, cannot convert from double to float. So it's actually evaluating that this is actually a double type, but we know that this is in the range of float, right? So in Java, we can see this kind of weird error message. But again, since all the decimal numbers are being, maybe I would say default, the default decimal data type value is actually double. Okay, so that's why in order for you to overcome this issue, you will just write F, and that would be acceptable. So if I'm going to print this one out, I will write pi. So print pi. So yeah, this one 3.1416. So F is not included during the printing because F is telling this literal is telling telling the compiler that this is really a float, not a double. Okay. So um so I recommend sticking to the double for convenience, especially for rational numbers, okay? So that's what I actually mentioned in the previous video, but I just would like to repeat myself, okay? So let's talk about integer literals. Okay, so we have numeric literals, but these are literals with decimal point, okay? Let's have integer numeric literals. So decimal numeric decimal numeric literal, sorry, we have here integer numeric literals. Okay, put semicolon in there. Okay, anyway, my brain is used to putting semicolon. um, for integer literals, I recommend that you stick to the int type because if the default of decimal is double, the default of the integer is actually int. So stick to the int, I would say, and but as long as you have a compelling reason in choosing byte or short, then you can do so. As I have mentioned in the previous video, integers that are more than 9 digits will raise an error if you don't literally put the long type. So try to see this example here. If I'm going to write int one int that is 9 nines, let's see, 1 2 3 4 5 6 7 8 9. Okay, so as you can see, it it is accepting 9 nines, but when you make it a 10, it is already a syntax error. Okay, so as I have mentioned, in order to overcome this one, you can change the data type into long and then put L, and then that would be okay. Okay, so that's how you change things. But if you're working only for a smaller number, so I would recommend to always use int if it's an integer type. Okay, so like that. So I'm going to print this one out so you can see the result. 9 nines. Okay, and let's go on the program. Okay, so that's how it is. Okay, next. So also Java actually supports another kind of another kind of, hold on, I just need to make it like better so that you can easily read this one. Okay, hold on. We'll try to make it better so it's readable, so that our style is, I think this one is better. Okay, Java also supports literals for binary. So literals for binary, octals. I mean, okay, Java also supports literals for binary numbers, octal numbers, and hexadecimal numbers. So let's try to quickly give examples for those three types of literals. So literals for binary numbers. Okay. So what are binary numbers, by the way? Can you tell me what do you know what binary numbers are? Okay. Binary literals are actually numbers that starts in Java, it starts with 0b, or you can also write 0 with a capital B. That's actually allowed, then followed by strings of zeros and ones only. Okay, so let's try to have an example. Okay, so let's say we have um, a binary data type. Let's try to stick to the int, right? So int, we have binary equals 0b 10. Let's just try to input numbers randomly. Okay, so you see it's valid data. Let's try to print it out. What does it look like in Java? So binary here, and let's see. Okay, so this is equivalent to 23. This is equivalent to this decimal 23. Decimal, there's no decimal point there, but this is a decimal numbers. Okay, so there's a way to convert this one into decimals, but I will not touch that one here. I will not explain further on how it's being converted, but there are available resources online where you can actually explore. Okay, so that's for the binary. Let's try to have the other literals, the one that I just mentioned. Let's have the octals. Okay, octals, octals, uh, octals. They are actually literals as well. You can actually assign them as literals. So since Java supports octals, let's try to define what octals are. Octal numbers use digits, numbers that use digits 0 to 7, okay? And if you assign a numeric literal that starts with 0, you need to be very careful because that will be interpreted by the compiler as octals and not the number that maybe the number that you want to emphasize. Um, for example, we have another example here. Int, I will write int, and let's say octal equals to 040. What do you think is the answer if we're going to print this one out? Do you think this one is the number 40? Um, let's try to print octal. Okay. Okay, if try to think, what do you think is this the answer if we try to print this octal, the value of octal? The answer is actually 32. So it means this 040 is actually 32 in terms of the number that we know, the counting numbers that we know. Okay, so that's the equivalent to the decimal number 32. Okay, next we have hexadecimal. let's try um, to define hexadecimal literals. Hexadecimal literals, on the other hand, they use numbers from 0 to 9, okay, and letters from A, sorry, A to F. So A is actually equivalent to 10 and F equivalent to 16. So from 10 to 16. So hence it's called hexadecimal. Okay. So let's try to have an example here. Int, another int type, hexadeci. Okay. So let's try to this hexadeci, so you can see how 0x FB 7A. So again, this one can be a small letter or a capital letter. It depends, and the value will still be the same. Okay, so that's equivalent to a value that has a capital letter X. So what is the equivalent value of decimal number here, of hexadecimal? Let's see. The answer is no, we did not print it yet. Sorry. Okay, let's try to print it out. Hexadeci. Let's try to print it out. The answer is this one, 64,378. So that's the decimal value of hexadecimal. So and there are so many resources out there online. You can see and check how hexadecimal it can how to convert hexadecimal to decimals, octal to decimals, binary numbers to decimals. Okay, so just in case you will stumble upon these characters in other people's program in the future, then you will know that they are actually octal number, I mean, special numbers, I would say, that are supported by Java. So they are not really, they are, especially the octals, they are not really that used. They are not commonly used, I would say. And but just to give you an idea that they are supported by Java programming language. Okay, so let's also let's have another literals that Java supports. So Java supports literals underscore literals. So sometimes when you have a very, very long digits, like um, the one that I actually gave earlier, like this one, I gave you an example about int 999, but you cannot really distinguish how many nines are there, how many groups of nines are there. So we usually put comma, right? But comma is not, so every three numbers we put comma like that. But in Java, it's a syntax error. So in order for you, if you want to read it properly, there's also another one called underscore literals. Okay, so we have another example here, int. So we I would say um under underscore equals, so we say 85875 675 432. Okay, we can do like that. So it is really acceptable to do like that. So underscore literal. Let's try to run this one. And you see the underscore is being removed when it's being interpreted by the JVM, okay, by our interpreter. So when it executes the program, it just removed the underscore. But yeah, this 875.675.432 is just the same as this one. Okay. So it's just so happened that it provides us readability, much more readable compared to this one without the underscore. Okay, so this is syntactically correct, and this is a literal. Okay, so another one is um let's have the Boolean literals. Okay, Boolean Boolean literals. So for Boolean literals, they are only defined either true or false. Okay, so that's um what the literal of Boolean data type has, true or false. So if it's true, then it's not false. If it's false, then it's not true. Okay, that's how easy it is. But yeah, they are booleans are used in conditional expressions that are very common in control structures. Okay, so example, let's have an example here. Double rate equals 0.05. Okay, and then let's say um hmm, hold on. Hmm, we can actually um assign a boolean type, boolean test. Let's say boolean test equals to, let's try to get some of the variables that we have already here. Let's pick let's say binary. Okay, binary is greater than the rate. Okay, so let's try to check if binary, which we know binary has what value is binary has. Binary has a value of um where is the binary? Okay, so binary has a value of third, no, as a value of 23. Sorry, I was looking for it. Okay, so it has a value of 23. Let's try to check test because it returns true or false. Okay, true. Binary is greater than 0.05. So that's how you use the literal of Boolean. Okay, so that's it for our literals, and please pause the video for a while and answer the given question. So I will be going to give you a question here, Q&A. So Q&A portion. So is the given value of this expression a literal? So I'm going to give you an expression, float. Float is literal equals, let's say, pi times, do you have another float here? Let's change this one to float so you can see float, and then we'll put f. Okay, pi times simple. So what do you think is the answer? Is the given value of this expression after this one is being executed, is the given value of this expression a literal? Yes or no? Okay, I hope we have the same answer. The answer is yes. The value of the expression will be a new fixed value, which is a literal of the type float value. So if we are going to call this one, um, let's try to call it. Can we call it? Let's see, is literal. Okay, can we do that? Can we, why do you think we cannot call? Because again, the compiler is evaluating from top to bottom. So it's like bottom and then it goes up. So this one is not correct. So we'll just try to move their place up. So it will be correct. Okay, syntactically correct. Okay, so now we can run the program and see. You see, it's a type float, 3.76992. Okay, so I hope you've learned a lot in this video, and I'm going to okay, I hope you have learned a lot in this video. Thank you for wasting your time or thank you for really watching and supporting this video. If you really like this one, please don't forget to subscribe and hit that like button. Okay, I am so eager to see you again. I hope to see you again in my next video. Okay, my next video, you'll love that one because that is a continuation of this literal content. Okay, see you again. Thank you. Bye.